The matrix R represents a rotation about z-axis. So from your formula booklet, it corresponds to the matrix of the very last line. So if you just copy that from your formula booklet, R is as such. And our matrix equation is AR is equal to B. And we want to find the A, so we're gonna multiply the inverse of R to both sides like this. As R multiplied by its inverse, it becomes a identity matrix, which is same as 1 in the scalar. So that means A times I is equal to A, because A times I is itself. That's the definition of the identity matrix. So left-hand side becomes A, and then the right-hand side is still B times R inverse. So let's first find the inverse of the R. In order to find a inverse of 3 by 3 matrix, you first have to find a determinant. Determinant of the arbitrary matrix A, B, C, D, E, F, G, H, I. This is the definition of the determinant X. First, you select a first row, first column element, and then you remove all its row and column. Then you have 4 components left, which gives you a 2 by 2 minor matrix. And then you're going to multiply with the circled component A. You do the same thing for B. And then you again eliminate row and column. You have 4 components left, which gives you other 2 minor matrix that's going to be multiplied with B. However, here the sign is important. It goes by plus, minus, and plus. Therefore, here is a negative sign in front of the B. And again, for C, you eliminate row and column. You have 4 components left. Find a minor matrix. And then you do first minor matrix determinants. You do EI, so these together, minus FH, so these together. So that's the definition of the determinant of 2 by 2 matrix. And then you do the same thing. So let's apply to our matrix R. So determinant of our R is up there. It is your first and first component, cosine theta, times by the minor matrix cosine theta, 0, 0, 1. And then you minus, and then it gives minus sine theta. And then you remove the row and column. You have sine theta, 0, 0, 1 left. And then the last term is 0, so you don't have to really worry about the last term. Then it gives cosine theta times by cosine theta, minus minus, so it's plus sine theta. And then it's multiplied by sine theta. So it's cosine squared theta plus sine squared theta. This is a basic rule of the trigonometry, which is always equal to 1. So our determinant is 1. So next step, we know our determinant is not 0, so we know it is inversible. So next step is to find the adjugate matrix. Adjugate matrix is a matrix of all 2 by 2 minor matrix of the transpose of the matrix. So let's go step by step. First, we have to find a transpose of the matrix. Transpose is switching your row and the column. So first row becomes first column. So our transpose of the matrix R, first row becomes first column, so cosine theta minus sine theta and 0. Second row becomes second column, sine theta, cosine theta, and 0. And then the last 0, 0, 1. Okay, so we got the transpose. So what is minor matrix? So you actually have done this. You eliminate the row, you eliminate the column, and then the remaining 2 by 2 is your minor matrix. So let's say our adjugate X has 9 positions, like that. each position corresponds to the same position in your transpose matrix, you eliminate that. And the remaining 4, the determinant of remaining 4 becomes a first number in your adjugate matrix. Now you can fill in the first position of your adjugate matrix, which is cosine theta times 1 minus 0. So that becomes cosine theta. So the second position, okay, that corresponds to sine theta in your transpose matrix. You can eliminate your row, eliminate your column. Now you have these 4 number as a remainder. So it becomes minus sine theta times 1 minus 0. So that becomes minus sine theta. You repeat every single point and then you get the adjugate matrix. So if you finish finding all determinant of 2 by 2 minor matrix, it looks like this. And the last term becomes cos squared plus sine squared. So that's equal to 1 again. Now, this is very important. Always remember, this is not the end of the adjugate matrix. You have to convert the sign wherever you need to. So it goes like this. It's plus, minus, plus. As I mentioned in the above, when we find a determinant, and second row becomes minus, plus, minus. And then the third row again becomes plus, minus, plus. So here, these 4 position needs to convert its sign. So that, and that. So this becomes plus and that becomes negative. Okay, so that's the end of the adjugate matrix. Okay, step 3 is actually finding the inverse matrix. It is defined as 1 over determinant times by your adjugate matrix. You have all the ingredients ready here. So your inverse of R is 1 over determinant, which we found as a 1, times by adjugate matrix, which is written up here. So it's just 1. So your inverse is actually this. And then we go back to our equation where we want to find A, which is B times by R inverse. I just copy the matrix B from above, and R inverse is what we just found. So if you multiply that together, you multiply row and the first column. And then you go, again, the same row and the next column, and such and such. Therefore, after the matrix multiplication, you get the A as such. Here, you cannot find theta, meaning that all the values won't be changed as the theta changes, because they don't have their theta in their terms. Therefore, our A is independent of theta. In order to find what matrix is doing in terms of transformation, the easy way is to multiply certain matrix or just arbitrary matrix called x, y, z. Now if you multiply ax, then let's see how this x changes. So if you do this multiplication, it becomes minus x. The other is all 0. 0 times y, 0 times z. And the second component becomes y. The other is again a 0 term. And then the last term is z here. So our original matrix x, y, z, after multiplied with the matrix A, it becomes minus x, y, and z. So if our x, y, and z is all positive, it should be all in positive x-axis. Let's say this is a positive. Let's say this is a positive, and this side is also positive, and this side is a positive. Then it should be in here, above orange plane, right to the green plane, and going towards yourself from the blue plane. Now, if the x only becomes a negative, this moves to here. So now left to the green plane, and all the others are the same, right? So that means that x prime, which is here, is a mirror image or the reflection in green plane. So this green plane is x equals 0 plane. So we can say that this matrix is doing a reflection in x equals 0 plane. In order to solve question 8, part A, you have to know what the Moivre theorem is. So it is equal to cosine theta plus I sine theta all power to n is equal to cosine n theta plus I sine n theta. As our z is equal to cosine theta plus I sine theta, this means that our z to the power of n is equal to cosine n theta plus I sine n theta according to the theorem. Now we want to find 1 over zn, 1 over z to the power of n. Most of the question in your A level doesn't like imaginary number in your denominator. One way to remove the denominator imaginary number, which is for us I sine n theta, is to multiply the conjugate of that complex number. Conjugate means that you want to multiply cosine n theta minus I sine n theta, because conjugate of the complex number has a opposite sign in the imaginary number. So we have minus I sine n theta here. As you cannot just multiply a random number to a fraction, you're going to multiply the same numerator on top of the denominator so that this whole part is just equal to 1. Multiplying 1 doesn't change any value. So you're going to multiply both of them on the fraction. Then your numerator becomes 1 times that equation. So cosine n theta minus I sine n theta. And then using a rule where a plus b times by a minus b is equal to a squared minus b squared. So if you compare denominator with this equation, we can say our a is cosine n theta and b is I sine n theta. Therefore, a squared cosine square n theta minus I squared is minus 1. And I squared is minus 1. And sine n theta also has to be squared. So sine square n theta. Now it's minus and minus, so it becomes plus. So cosine n theta minus I sine n theta all over cosine squared n theta plus sine squared n theta. And by using a rule where cosine squared x plus sine squared x is always equal to 1, and x here can be anything. For example, our x is n theta. So the denominator becomes 1. So that all becomes 1. So our 1 over zn is equal to cosine n theta minus I sine n theta. And here, directly using the theorem, we found that zn is as such. So if you subtract those two, you will get zn minus 1 over zn. It becomes 2I sine n theta. In A level, part B expects you to use a fact from part A. So I copied and pasted here what we've proved from part A. And the question has sine 5 theta, sine 3 theta, and sine theta. As we expected to use a part A fact, we're gonna substitute all n equals 1, n equals 3, n equals 5, because that will give you sine theta, sine 3 theta, sine 5 theta in your right hand side. So we're gonna write this at the corner, and then let's approach the question. Now the question is asking you to power your sine theta by 5. So it's using sine theta, so we're gonna use equation 1 here. So let's power our equation by 5. Okay, left hand side becomes z over 1 over z power 5, and then the right hand side becomes 2I sine theta to the power of 5. So here we're gonna separate the left hand side and the right hand side. So let's start with left hand side. Left-hand side requires you to know a binomial series, which I copy and paste here. So if you apply that to our equation, z minus 1 over z to the power of 5. So our az, b is 1 over minus 1 over z, and our n, which is power, is 5. So if you directly substitute into the binomial series, it will become like this. Faster way to do is your first a term always will have a decreasing power as such, whereas the second term always has increasing power like this, and then it follows the number in choose brackets. If you find a value of NCR using this equation, it simplifies to this. So this is why I started with finding all three equations by substituting n1, n is equal to 3, and n is equal to 5, because now we can combine terms with the same power. So for example, z to the power of 5, here, 1 over z to the 5. Z to the 3, 1 over z to the 3. Just z and 1 over z. Check that I make minus 5 in front of the bracket in order to make the sign of z3 positive, okay? So now if we use equation 1, 2, and 3, this becomes a trigonometry term like this. This is just direct substitution of equation 1, 2, and 3. So now our right-hand side. Don't forget you are only doing left-hand side. So right-hand side, which was 2i sine theta to the power of 5. So that's equal to 2i to the power of 5 sine theta power of 5. So 2 to the power of 5 is 32. I to the power of 5 is just I. Because I to the power of 4 is 1, and therefore I to the 5 is 1 times I, it's I, okay? And then sine to the power of 5 theta. So what I did is your left-hand side, which is in red line, it's just here. I just opened the bracket for the numbers. And that goes to here. As we want the sine to the power of theta 5 only, we're going to divide everything by 32i. So your answer is this. Again, question starts with the term hence. This means that you're going to use the fact coming from part B, sometimes part A, but more likely part B. So I copy and paste the answer from part B here. And then this is a integration question. So you have to know a basic integration for your trigonometry, sine and cosine in theta. It's copy here. Make sure you memorize this because it's not in your formula booklet. Okay? Now let's do a integration. But instead sine power of 5 theta, we're going to substitute right-hand side here. Then the integration becomes this. Now we're using integration of sine theta, so we use this one. In here, you have to be careful with your sign, and you have to make sure you divide the value by your n. So, for example, your first term becomes minus, because we have minus in front of it, 1 over 16 times by 5, which comes from this 5, okay? It's 1 over n multiplied. And then sine 5 theta becomes cosine 5 theta. You repeat that. Again, minus comes out, so it becomes positive here. 5 over 16, but we have 3 here, so multiply 3 here. And then that becomes cosine 3 theta. Repeat, revert the sign, 5 over 8. You have 1 here, so it just multiply 1. And then that becomes cosine theta. And we have a limit, so we're gonna put square bracket and pi over 3 and 0. Now for the limits, you're gonna substitute pi over 3 into all the terms. And then you're gonna substitute 0 into all the terms. And then you're gonna subtract 2. Like this. So first bracket comes from limit of pi over 3. And then the second bracket comes from limit of 0. In order to get all the cosine value into number, you're gonna either memorize this in order to really make your exam time faster. You just have to memorize these. Or you can change the calculator in radian angle unit and then find each cosine value. So using these values of the cosine, we get 53 over 480